Okay, I'm going to do example number 2 and 3 on this video. For example number 2, this is the equation of the ellipse. Under the x squared is a 25, under the y squared term is 169. The 169 is the bigger number. So this is going to be your major axis in the ellipse. You always look for the bigger number in the denominator. In this case, the a squared will be the square root of 169. A will be 13. And b squared is equal to 25. So b is going to be equal to 5. So you take the square root of these. Now, again, it's going to be taller in the y direction than the x direction because the bigger number in the denominator is under the y squared term. The center of your ellipse is HK, and the coordinates of the center are going to be 4, -1. Right, so I'm just going to do a real small drawing on this one, and guys, look at my notes and look at the graph paper in my notes. So if you start at +4, -1, +4, -1, that would be your center. From there, it's going to be taller than it is wide. You would go up 13 for a vertex, down 13 for a vertex from the center. So the coordinates of your two vertices, you would start at the center here. The x value is going to stay the same, and when you add 13 on to the y value, you get 412, and the other vertex would have coordinates of 4, and when you subtract 13 from that y value, it's -14. Now, the co-vertices are on the shorter diagonal, and you use your b value for that, so you go back to the center, you would go 5 units to the right and 5 units to the left. This would be a co-vertex. This will be a co-vertex. The coordinates of the co-vertices, again, once you do this on graph paper, you just kind of read the coordinates off of the graph paper. I mean, you could certainly use all of those formulas that were on the other sheet, but that's a lot to learn. This is the easier way to understand it. So you would start at your x value of 4, you would add 5 onto it, so one of the co-vertices would be 9, -1. You would start here with this x value of 4, subtract 5 from it, so the other co-vertex is -1, -1. And your ellipse is going to be taller than it is wide in this case. It's not supposed to look like a football, it really should be rounded. Label it with the original equation. Then to find the foci, you need the value of c, and c is equal to the square root of a squared minus b squared in an ellipse. So in this case, c is going to be equal to the square root, a squared is 169, b squared is 25, so c is going to be equal to the square root of 144, so c will be equal to 12. Your foci are always on the longer diagonal. The longer diagonal is in the y direction for this one. So you would start at the center, you would go up 12 to find one of the coordinates of your foci, down 12. So the coordinates of the foci for this ellipse, you would start with the center, keep the x value the same, and do -1 plus and minus 12. Now in this case, you would actually work it out to be integer values because there's no radical. So the coordinates of the foci, 1 is going to be 4, -1 plus 12 is 11, and the other foci would have coordinates of 4, -1 minus 12 is a -13. And then the eccentricity of this ellipse is c over a. The eccentricity, c is 12, and the value of a up here is 13. Then the last example gives you an ellipse in general form, and you have to change it into the form where there's fractions and set equal to 1. So the last example is x squared plus 4y squared minus 6x plus 4y squared minus 6x plus 5 equals 0. Okay, so I'm going to start by grouping my x terms together. X squared minus 6x. I'm going to leave some room in there to complete the square. Then plus 4y squared. there's no other y term, equals 0. To complete the square on this, oops, I forgot about my 5. When I bring the 5 over to the other side, it's going to be a negative 5. To complete the square on the x's, half of negative 6 is negative 3. Negative 3 squared is a positive 9. There's my perfect square trinomial. Because I added 9 to the left, I have to add 9 to the right of the equation. So this over here is going to be a positive 4. The factored form of this perfect square trinomial is x minus 3 squared plus 4y squared equals 4. Now, we need to make this into an equation with fractions and the number over here equal to 1. So what you would do is you would divide everything by 4. I'm dividing by 4 because this will make this a 1, and it'll get rid of the coefficient over here. So the formula for graphing this ellipse is x minus 3 squared over 4 plus y squared over 1 equals 1. And now it's in the right format to graph it. Because the bigger number is under your x squared term, this is going to be an ellipse that's bigger, wider in the x direction than in the y direction. And in an ellipse, you always look at the denominator that's bigger, and that's your a squared. So in this case, a squared is equal to 4, and a is going to be equal to a positive 2. B squared is equal to 1, and b is going to be equal to a positive 1. The center of this ellipse is HK, so you use your x value, which will be 3, and there's no number added or subtracted to the y, so it's going to be 3, 0. So to graph this ellipse, you would start at the point 3, 0. That's your center. Because it's going to be wider in the x direction than in the y direction, you would go 2 units to the left for a vertex, 2 units to the right is the other vertex. So the coordinates of the vertices of this ellipse are going to be 1, 0, and 5, 0. 1, 0, and the other vertex is going to be 5, 0. You would go up and down the b value for your covertices, so this would be a covertex, a covertex. So this ellipse is going to be wider than it is tall, and look like this. Of course, you're going to label it with the original equation. The coordinates of the covertices, you would start with the center of the ellipse, and you would add 1 to the y value. So one covertex is 3, 1. The other covertex is 3, negative 1. To find the foci, you have to find the value of c. c is equal to the square root of a squared minus b squared. So in this case, c is going to be equal to the square root of 4 minus 1, the square root of 3, and you would add and subtract that from your x values of the center because it's on the longer diagonal. Again, follow my notes, and I think you'll understand this. I hope you're all doing well.